After stroke, people commonly have difficulty transferring body weight from the non-paralytic limb to the paralytic one during voluntary movement. The impaired weight transfer can be visualized by the unequal ground return force during walking. Insufficient lateral weight transfer is shown to affect propulsive force and is associated with decreased walking speed. During the weight transfer process, regulating limb stiffness is critical, where excessive stiffness may cause high impact and insufficient stiffness may induce limb collapse. Stiffer joints are frequently observed among people who have had a stroke, but whether it affects the weight transfer process remains unknown. To study the weight transfer process, which was hardly seen during voluntary movement in stroke population, we've developed a novel perturbation to generate impulse lateral weight transfer. Here's a demonstration of the perturbation. The support surface drops 4.3 centimeters, facilitate lateral weight transfer to the drop side. During the weight transfer process, two phases are involved. It begins with leg compression to mitigate the impact, which is named the impact absorption phase in our study. Regulating limb stiffness is important in this phase. After the impact absorption phase, the leg discontinues to shorten, but the body center of mass keeps shifting toward the drop side until maximum weight bearing is reached. In the current study, we want to investigate whether clinical assessments of motor recovery and dynamic standing balance are related to leg stiffness regulation and maximum weight bearing during perturbation-induced weight transfer in individuals post-stroke. Let's take a look at the results. Among all three clinical assessments, we found that people with lower CMSA foot score had greater leg stiffness during the impact absorption phase. Looking at two components related to stiffness regulation, change of leg length and vertical ground return force, people with lower CMSA foot score had less leg compression during the impact absorption phase. We've also found that people with higher step test performance had greater maximum weight bearing at the end of the weight transfer process. So in conclusion, our study suggests that CMSA foot score reflects the ability to flex lower limb in response to rapid loading, which is likely the cause of a stiffer limb. Also, the voluntary stepping performance appears to be limited by the maximum weight bearing capacity during post-weight transfer. In the future, we will investigate whether clinical assessment score can be improved by repeated exposure to impulse weight transfer. So thank you for being interested in our research. Feel free to contact us if you have any comments or questions. Hope you're staying safe and enjoying the virtual meeting.